What is going on, everybody? Welcome back to the Blackboard. In this video, we're going to be doing some examples with solving linear systems. It's going to be a linear system with two equations, and then in the next video, or there will be a couple, or probably just one example, where we go with a three equation system, which will be slightly longer, but we're gonna, start off with, the basics, get the momentum going. And so we're gonna do, I believe, two examples on this video. One of them is gonna be a long one, and then the other one I might just not do. It could be for you. So for you to do in free time, but let's actually get started. So we're gonna do the first one, and the first one, the first example is find the general solution of the linear system. And so that one is, well, for part A, we have x1 prime is equal to x1 plus 2x2, and then x2 prime is equal to 2x1 plus x2. If you remember in a couple of videos ago, you can just solve this by converting this to a second order ordinary differential equation and then just using one of those methods to solve them. But this is going to be a different approach in case your professor is just like, don't use that. So we're going to go ahead and do this one. So the first step, which is probably the most crucial step that you should always do, is convert this system into an equation, or not an equation, into a matrix. So what we're going to do here is we're going to put this into a matrix, and this is as simple as just writing everything and then just kind of putting brackets, and then separating your constants and variables. So for the first one, it would just be 1, 2, then second row will be 2, 1, all multiplied by x1, x2. If you remember the linear algebra series on how to do that, good for you. If not, this was like a very quick recap, but I do suggest looking at that video. So now the next thing that we have to do is we have to find the determinant of this 2 by 2 matrix and set that equal to 0. And so what this becomes, we essentially get 1 minus lambda 2, 2, 1 minus lambda. Forgot to mention, it will be the determinant. It's like we are solving the eigenvector equation, where you have some matrix times some vector is equal to lambda times that vector. And so we are going to incorporate that lambda. But yeah, I did this on the lecture video. So this is going to be equal to 0, so we're going to do 1 minus lambda quantity squared minus 4 is equal to 0, and this is equal to 1 plus lambda squared minus 4 minus 2 lambda, which is lambda squared minus 2 lambda minus 3, and then we can write this as lambda minus 3 times lambda minus 1, and so we have lambda being 1 and 3. Cool. So we have our eigenvectors, and now all we have to do is find our eigenvectors. So let me actually use a different color so we don't get confused. So when lambda is equal to 1, we will get the matrix. Crap, this is wrong. This is supposed to be a plus 1 because it's negative. Whoops. So when, and then this would make negative 1. Okay, cool. So that changes everything. So now when lambda is equal to negative 1, we will get 1 minus negative 1 is 2. So 2, 2, 2, 2. And we want to multiply it by some eigenvector, v1, v2, such that this would be 0. That makes our eigenvector be, well, just 1 and negative 1. And then, so when lambda is equal to 3, you will get 1 minus negative 2, 2, 2, negative 2. And so the eigenvector will be, should be just 1, 1, 1, 1. And that's it. You have your eigenvalues, you have your eigenvectors, And so all we have to do is just put them into the solution. And so our solution will be x1, x2 is equal to, there's a couple ways to write this. So one of the ways to write this is constant, and then one of the eigenvectors, 1, which will be 1, 1, multiplied by e raised to that corresponding eigenvalue, which in this case will be 3, multiplied by, this is all in terms of t, so this will be x prime of t, or like x1 of t, plus the second constant times the other vector, 1, negative 1, multiplied by e to the negative t. Or another way to write this, which is more like non-matrix way, x1 is equal to c1 e to the 3t plus c2 e to the negative t, and then x2 is equal to c1 e to the 3t, that is a terrible 3t, minus c2 e to the negative t. And so what I just did there is just kind of, this portion will be x1, this portion will be x2, and then I just copy the c1, the c2, and then the e3. Just kind of like multiply them in, just kind of put them together and separate them. So yeah, that was pretty much it for the first example. The second example will be, the second example will be C, mostly because I ran out of space here, but that leaves part B for you to do. And so part C, again, we are given 2 equations, and then we have 2 unknowns, so we can find the solutions, theoretically. And so let's actually get started. So remember, the first thing we're going to do is put this in a matrix. X1, X2 is equal to negative 3, 6, 4, negative 5 times X1, X2. And then we have to set, or we have to subtract it by lambda times I being the identity, and then taking the determinant of that and setting it equal to 0. And so this will give us negative 3 minus lambda, 6, negative 5 minus lambda, 4, and then this is equal to negative 3 minus lambda times negative 5 minus lambda minus 24, or lambda squared plus 15 minus 24, 5, 9, so it'll be minus 9, and then 3 plus 5 plus 8 lambda, and so this will become, factor it out with lambda, so this will be minus 1 times lambda minus 9, right? No, that's 8 lambda, so one of them is positive. It will be plus 9 is equal to 0, so lambda will be equal to 1 and negative 9. So we have our eigenvalues, so now we have to do is find the eigenvectors. So when lambda is equal to 1, we'll get the matrix negative 4, 6, 4, negative 6. And so that eigenvector will just be 1, 1. And then for lambda is equal to negative 9, we'll have, oh no, this will just be 6, 6, 4, 4. So the eigenvector will just be 6 and 4 is 12, 3. So this would be 2, negative 3. Our solution, putting this all together, will just be x1, x2 is equal to, gotta put in the constant, c1. So the first vector, eigenvector, will be with the eigenvalue of lambda 1, so e to the t, plus c2 times 2, negative 3, e to the negative 9t, or x1 is equal to c1 e to the t plus 2 c2 e to the negative 9t, and then x2 is equal to c1 negative c1 e to the t minus 3c2 e to the negative 9t. So that is pretty much it for these two examples. You can go ahead and do part B in your free time as like a challenge. I will give you the answer so you don't have to like go ahead and look it up. So for this one, we'll have x1 equaling, actually I'll just write in matrix form, x1, x2. This would be equal to c1 7 1 e to the 5t plus c2 e to the t negative. And so this is my answer. I will say it is possible that you get a different answer, mostly because to find the eigenvector to set that equation equal to 0, there's like an infinite number of solutions, but this was one of them, and this one I believe is one of the simplest ones, or like the most reduced one. So yeah, this should be probably like the most common answer you get, but go ahead and try it when you can, and then compare it with this one. I'm pretty sure I'm correct. If not, then I can correct me in the comments. But yeah, other than that, I'll be seeing you guys in the next video where we do more of this, and it's gonna be a different scenario. So bye.